Kia ora, nice to see you guys. So the first, I think one of the first experiments that you could do with a junior class, year 9 or 10 class, is to, this is a situation where it's the first time probably that they've seen you. You might have had one lesson with them discussing some rules about the science lab and stuff like that. And this little task is really not just to measure skills, but it's really about how they get along together in groups and stuff. So I would definitely spend a bit of time talking about how they work together in, say, twos or threes. So get them in pairs or threes. Nominate someone who's the technician. So that's the person who comes up and gets the gear. So the first experiment that I really like doing, and I've been doing this for years, is the candle in the jar. So it's really simple. All you need is a tea light candle, or just a normal short candle, a box of matches, and probably about 3 or 4 jars. And collect the jars and just keep them in a tray. And you can use this many times. Particularly for year 9 and 10 classes. So what you're after really with the class is talking a little bit about scientific inquiry, like, what have we got? What sort of predictions have we got? Are there any questions about what's going to happen when we light this candle, and when we invert the jar over the top? Is it going to take? Most people will know that it will take longer for the candle to go out and burn, in a larger jar, because we know that there's more oxygen, more air in the jar. But the key for this is not only measuring the burn time of the candle, but also the volume of the jar. So I get students to tell me, well, how would we work out the volume of the jar? What would we do? And some say that they can measure the jar, measure the diameter of the jar and work out mathematically the volume. But one of probably the easiest methods in the science lab is to just use a measuring cylinder or measuring jug. So you fill up the jar with water, and then just pour that into a measuring cylinder, and immediately you can measure the amount of air. Use the same amount of volume of water, but you equal that to the amount of air in the jar. So the other thing too is that many students won't, especially with year 9, they won't be familiar with lighting a match. Now it might seems a bit sort of crazy with that, but a lot of the students will come from home and they've never, mum and dad probably have said, oh, I don't think it's safe for you to light matches. So this may be the first time that they come into your science lab and light a match. So, you might need to spend 5 or 10 minutes just lighting matches with the kids and just get them confident about lighting a candle and knowing what to do. So, tilting the match, lighting the candle there like that. Maybe talk a little bit about burning. What is burning? How does burning occur? So those are good questions to ask. So in terms of writing up the experiment, probably the most important things are these 5 kind of points. So I suppose the first thing would be a little class discussion on, what they think what will happen? Have they got any questions? And most scientific inquiry comes through questions. It comes through asking a question about the world. We might observe and make sense of what's happened, but there might be questions too about what's happening and why they think is happening. And then of course they might not use these words like equipment. They might just think, oh, what are we using? So you have to kind of like use the correct kind of terminology that we use in science labs. So instead of using what we use, we say equipment or materials. Then you might want to go over what a method looks like. A method is what we do. It's what we did in the investigation. Okay, so maybe some steps like a cooking demonstration. You know, step one we got the candle in the jar. Step two we burnt the candle. The other thing is that they have to measure the time that the candle burns for. So they'll have to use their phones or maybe a stopwatch, okay, to find out, and work out the timing of that. And then, of course, is results. And results go usually, in science, we use a table. So usually a table of results. And again, you need to write that up and model that in front of the class, what that actually looks like. And then, of course, the last thing is discussion. So having a little, maybe just a few sentences about why they think this has happened and what the relationship is between these two things. So this is what you would have on your whiteboard. You'd have the volume of jar, which is in mils. I mean, you don't have to have the volume of the jar. I mean, if you wanted to make it really simple, you could just call it jar 1, 2, and 3. But of course, it's the time that you're wanting that the candle burns for when the jar goes over the top. That's what you're wanting. So it's the timing of when you put the jar over to the time that the flame goes out. That's what you're after. So you could easily set that up and show them and model that to them about how that works. Then if you want to do one step further, you could actually get them to graph the results. So graphing's a modelling. It's a visual model of what the results are. And again, some students, particularly at Year 9, they will struggle with graphing. So again, it might be something that you could just introduce in the next, in the few lessons about how they do that. You could talk about variables here. The volume of the jar is an independent variable. I mean, I'm not sure whether you want to start talking about that, but you could certainly talk. You could start initiate that. And this is the dependent variable, the burn time. Maybe that's more Year 10. Anyway, I'll leave that up to you. How you'll gauge where the students are at, what kind of developing their understanding is. So obviously you'll see that this is hopefully that this is a linear relationship. So the larger the volume of air in the jar, the larger the jar, obviously the greater the burn time. So it's a linear relationship. So I hope that helps. It's not just we're not just talking about scientific inquiry here. We're talking about what are these students that you've got in your class. You're just getting to know them, how they work together. You're talking about the rules of the lab, all that sort of thing. But this is a really lovely experiment to do with them, and really not much can go wrong apart from maybe a broken jar. But really good start to what we mean by scientific inquiry. Thanks very much.